Hi, my name is Kurt Romans. I'm the president of Travis Industries. We manufacture the Lopi stove here in Seattle, Washington. On behalf of the 500 families that work here, thank you for choosing a Lopi. You know, it was over 3 decades ago I built the very first Lopi stove. In fact, I made up the word Lopi. I coined a word out of Lobo Wolf and Hopi Indian. It sounded wild, it sounded like the sky's the limit. The sky's been the limit. Over 1.5 million families in North America have chosen the Lopi stove for their home. Let's take a look back at the very first Lopi stove. This stove was made to install in a fireplace, circulated air around it through a convection chamber, a lot of radiant mass here. It's a well-built stove. It's 30 years old and it's just like it was made 30 years ago. But these stoves burned hot, heated a large area, but we had very little regard for emissions. They created smoke. Didn't give it much thought. Over time we learned that there was a negative impact on the air shed. So 20 years ago, in earnest, we started a research program how to make wood stoves more efficient and cleaner burning. The stoves of today are remarkably different. This stove created about 50 to 60 grams of emissions per hour. The typical stoves in the market today are between 2 and 6 grams an hour. This new Lopi stove, the Cape Cod, is the cleanest burning stove in the world. It's a whole new level of emissions reduction and high efficiency in wood heat. It's a game changer. This stove burns at 0.45 grams an hour, and it's a huge stove with a big viewing area. Let's take a good close look at your brand new Lopi Cape Cod. You are going to love your new Lopi stove. I'm going to go through the details and make sure you understand all the features, all the nuances about this product. And we'll start it for you in just a few minutes. We'll get one loaded up with fuel and we'll get it started. But let's start at the top of the stove. Up here we've got a cast iron flue collar. We'll take a single wall pipe or double wall connector. A double wall connector, if you can imagine, it's 2 walls, so it's not radiating as much energy to allow us to get the stove pretty close to a combustible wall. So if you don't have brick or if you don't have stone on the wall, you can put this up 11 inches with a double wall connector. You can put this 11 inches away from a combustible surface. The stove itself, the biggest impact of this stove is the beauty of it. You're looking at the proportionality, the fit, the finish, the depth, the width, the height, the size of the glass. It is one of the most beautiful stoves ever made. It's got a serpentine flow to the front of it. It curves in, comes back, comes out, and goes back in. And again, the choice of moldings, it's exquisite. This stove was co-designed with a couple of designers out of Vermont, Vance Smith and Al Wilker. They're masters at design, and they worked with me for over 2 years getting this stove just perfect. So you look at this beautiful stove and you see it's got a finish on it, a porcelain finish. This is a Magelica finish. We actually bake a white enamel on first, then we put this chocolate brown, this deep brown, rich brown on it, bake it again, and on the edges, on the sharp radiuses, we have that brown finish work off of that edge and you get a little bit of white highlight. Very subtle, but again, very, very warm. As we come down, look at this beautiful molding around the top of the stove. We'll notice there's an opening underneath it. This is one of the most outstanding features in this cast iron stove. It's a full convection chamber like every other Lopi stove I've ever made, going back to stove number 1. Convection doesn't give us more BTUs to work with. It helps, though, about 50% more circulation throughout the home. So you can heat a larger home and more floor space with getting air around the stove. It works without power, or you can enhance it with the blower. The idea is simple. There's a chamber here. As that air heats up in that chamber, it expands, rises, it's forced out the front of the stove. So it'll replace itself naturally, or you can enhance that flow with a very powerful, quiet blower. This blower is about 400 CFM. It'll circulate air out the front of the stove, and again, it'll help get to the back, the further rooms away from where the stove is located. So you've got a beautiful design, you've got a porcelain finish on this one, you've got a convection chamber. The next thing that's really prominent in this design is the viewing area, the huge viewing area. You've got, it's like an open fireplace. This should be a freestanding fireplace, not a stove. Think of this as a fireplace, not a stove. And you have a viewing area this large, you've got to have some technology to keep that glass clean. Built inside the stove is we got preheated air coming over the door and rushing down in front of that glass to keep that glass clean as you use it in your home. Notice it's a single door. There's a handle on one side of it. Hinges are concealed behind the molding detail on the other side, but this opens up easily, swings wide open for easy fuel loading. A couple of andirons will keep logs from rolling out onto the hearth. Huge firebox capacity. You see it's all fire brick lined in there for durability. It helps keep the temperatures up. And let me talk just for a moment about how this stove works. We said earlier, this is the hybrid fire stove. The word hybrid would imply there's several technologies going on simultaneously. And what it is, this is the best of two worlds. We have what we call a high-tech stove, which is non-catalytic. We've been doing that stove for 19 years now. Those stoves work on the principle of the 3 T's: time, turbulence, and temperature. As we give it time by baffle slowing the flow down, we have brick liners that elevates the temperature of the box. Then we add secondary air high in the fireplace, which creates turbulence. So you have fresh oxygen. You have what used to go out of the stove as smoke or creosote being burned up. Every Lopi stove we make has that. This one has that. In addition, it has a catalytic combustor up high in the stove to reburn or assist in burning anything that didn't get burned up in that secondary stage. So there's 3 levels of burn in this hybrid stove. That's what gets our emissions down to under a gram. Again, a big firebox, 0.45 grams of emissions, and that's an average of low, medium, high, and high burn. That's just not the best sample we've got. That's an average of the entire burn spectrum. So this is an EPA certified stove, and again, it is the cleanest burning stove ever tested. It raises the bar, and what you're gonna notice as a user of the stove is the efficiency. Since it burns so clean, the efficiencies are driven up, and you'll burn less fuel to heat your home. That's the payoff right there. We've got clean air, pays off for all of us in the community, and you've got more efficiency, you'll burn less wood. You close this large door. To operate this stove, there's a single air control. It's located right below the door handle, and you pull it out towards you, you're letting more air in the firebox. When you push it in, you're slowing that combustion rate down. What this handle does, it meters air to 3 distinct parts of the firebox simultaneously. It goes to primary air by the base of the fuel, the tubes, the secondary tubes high up in the stove, and then some of that air is preheated and delivered over the glass for that air wash to keep that glass clean. You don't have to think about it, don't have to worry about it. It's being done automatically for you as you manipulate a single air control. You push it in, you get that long overnight burn. There's another control mechanism. It's called a bypass damper. It's located up in the rear corner of the stove, and you want to open that or pull it out towards you. What that does, it gives us an open exit for the flue gases to come up the chimney. So when you're starting your fire, you want a direct path for that gas to rise up to get that quick hot start. The other time you want to use it is when you're loading extra fuel. When you're adding new wood to your unit, open the door, open the bypass damper, open the door, put your fuel in. Once you've closed your door, shut it down again. So it's really a matter of getting that all the gases going where we want them, is up the chimney, not in the room. The other killer feature I want to talk about in this stove is an ash pan. Gosh, it's just the most incredible ash pan ever designed in a wood stove. It's located beneath the bottom of the stove, and there's a handle down here, you click it down, draw this out. This is on high temperature ball bearings, like draw glide in your kitchen. What it does, it brings the ash pan out, easy access for it. You get this metal ash pan, and I find here in the Northwest, during burn season, we're removing this about once a month. What we recommend for you to do is get your burn pattern going with your species of wood, whether you're burning maple or burning fir. You want to see how fast that ash accumulates in your fireplace, and then get a schedule to remove it accordingly. So here, it's about once a month I take it out, and here's something else to be very aware of. What looks like just ash in there always conceals some embers. Be very careful not to empty this into anything but a metallic, non-combustible container. Sure, you can take the ash outside and spread it in the garden, that's fine, but you really want to make sure you take this as a live coal bed. You consider it to be, for safety's sake, make sure you put this in something non-combustible. To put it back in, you slide it in place, hook it over the front of this mechanism here, drop your handle down, and just slide in and lock it in place. That lock mechanism gives you an airtight seal. You don't want air leaking under your fireplace, which would affect your burn times. Also, a little tip here, Only empty your ashes when your fireplace is cold. You never want to do that when you have the fuel in the unit's burning. "100 years ago, an inventor named Charles Kettering did a demonstration in the parking lot for the executives of the Cadillac Car Company. He demonstrated how to start an automobile with a flick of a switch. That was the end of cranking the automobile over. Well, it took us at Lopi 100 years to figure it out, but with this stove here, for the first time, exclusive to Lopi, we have a push-button ignition system called the Green Start Igniter. Simply put your kindling near the source of heat, put your logs on, push the button, and the fire starts, takes all the hassle out of starting a wood stove. Let's go take a look at this fine stove operating. I've asked Russ McBrien, one of the lead designers on this Cape Cod stove, to join me. Russ is going to show you how to use the air control, the bypass damper, how to set kindling to get a great fire, how to use the accessories, the Green Start Igniter, the powerful fan, and even the ash pan. Russ is our resident expert. Russ, you ready for this?
I am, Kurt. Thank you. I'll take it from here.
Awesome.
Here at Travis Industries, I got the best job in the company. I get paid to sit and watch fire. I've watched the fire in this stove for probably 1,000 hours. I'm excited about showing you guys all the great features on this stove. Right now we're going to talk about the best innovation in wood stove technology in the last 100 years. This is the push button Green Start. It works through an igniter system that blows hot air onto the wood and lights the fire. If you look right back here, there's the end of the igniter, and what I'm going to do is show you how to stack the wood on that igniter to get a nice effective start. So what I'm going to start is by putting a piece of wood square across the bottom, flat, and then I'm going to take some small kindling, and the key to get a good fire going is to get some wood right in front of that igniter. You want the igniter it blows out hot air over the wood at 1400 degrees and lights it on fire. So you want the wood to be placed directly in front of the igniter so the hot air will blow along the length of the wood. So if I just stick some of my small kindling in here right on that igniter and get enough in there so when it catches fire we'll have enough to keep everything going. And then after that, you're going to want to completely fill your stove with a full load of wood so you don't have to tend it after we start it until it's time to load it again. So I'm going to stick some more wood right here on top of that in front of the igniter. So the key to get a good wood stove or a good fire going in your wood stove is spacing between wood. You need some smaller pieces of wood, but it's crucial to leave an inch or two of spacing in between the wood so as it catches fire, the heat from the fire on both pieces of the wood can build the fire and spread it throughout the box. So smaller, and as I load the wood up fuller, I'm going to use bigger and bigger pieces of wood. So then at this point, I can go ahead and just use normal size wood on the fire. Get a nice load in here. As the fire spreads from the igniter through the wood, the air is going to blow the fire like a billows up through the stack of wood and get the whole load going. Now I've taken the large wood back out of the stove, so what we can do when we get the Green Start ignition system going, we'll zoom in and show you exactly how it interacts with the igniter, how the fire starts and spreads throughout the fuel load. Once you get your fuel load in there like I showed you earlier, you just need to shut your door. It's important that your bypass damper is in the open position and that your primary air is pulled all the way out in the open position so the fire has enough air to continue on its own once the igniter system quits. That Green Start ignition system, that was easy, wasn't it? For those of you who are not going to buy the Green Start ignition system, there are several ways to start a fire. Everybody's going to develop their individual strategy on how to get a good fire in their stove. There's the TP method, the tic-tac-toe method, the top-down method. There's also some instructions in the manual about getting your fire going. So I'm going to demonstrate a traditional, what we call the top-down method. And what I do is I put some big pieces of wood in the bottom of the fireplace and make sort of a bowl that we fill with paper and kindling, and then build the fire up from there. So I'm going to take the first piece of wood and put it horizontal back across the rear of the stove. And then the next two, I'll just kind of enclose it and make a bowl. And the reason I put the rear piece of wood horizontal across the back is because in all Travis Industries stoves, right here there's a primary air orifice that introduces air into the bottom of the fire. This is crucial for startup. Once your fire is established, you got a nice coal bed, you can load your wood right on top of that. That's not going to matter. But for startup, when the fire's going, it's crucial that we have air delivered underneath the fire to blow up between it and spread it throughout your load of wood. So it's important with paper too. Newspaper, color print on your regular newspaper, that's going to be fine, but you want to stay away from the really glossy print papers that you get in the advertisements. The more ink, the worse it is. So stay away from the glossy stuff. Your regular newspaper, that's just fine. You also don't want to crumple it up super tight. You want it to be nice and fluffy. That'll get the fire going nice and hot and quick for you. So the better you get at lighting your fire, the less newspaper and kindling you'll have to use. What you're going to want on top of your newspaper is some really small kindling. And it's really not important on how you put it in here, except that you want air between all the wood, so the fire can burn up through the pieces of wood and catch everything on fire. If you have it stacked in there nice and tight, you're just going to get fire on the outside and it's not going to spread very well. So I usually just put one layer of wood down, then change your direction 90 degrees or so, run another layer down. And like I said, the most important part is that you have spacing in between your wood. So as you build it up, you're going to use bigger and bigger pieces of wood. All right, change directions, make sure you got some spacing in there. And then just like with the green start, once you get your fire going in here, you don't want to have to open the door and reload it really quick. So you want to go ahead and fill your fireplace up with wood. Again, using larger and larger pieces as you build up. The spacing again, you can see how I'm leaving the wood spaced apart. You can even put some bigger pieces over here on the side, so as it burns down, they'll fall on top of the fire. So that's a pretty good starter load right there. And what you're going to do is light the fire right here at the front, usually over on this side. Once the fire or the paper is lit, what we'll do is shut the door. And there's a little secret to this. If you leave the handle down, the latch will catch, and that'll give us an air opening or a crack along this side of the door. Now the fire is based on a draft. The hotter the chimney is, the more air it's going to suck in. So as the stove heats up, it's going to pull air in here and fan the fire from this side all the way through and throughout the load. Now it's time to light your stove. A couple more things. Make sure that your primary air is pulled all the way open and your bypass damper is pulled out to allow a straight draft up the chimney for your flue gases. So depending on how well you start your fire and how dry your wood is, usually between 15 minutes and 30 minutes, your fire will be established well enough to close the bypass. We provide these gloves in the hardware pack. Remember, the stove gets extremely hot during operation. Also is the primary air control, which is located right down here underneath the door handle. Right now, it's pulled fully out, which is a high burn or wide open air. If you shut this, you should see a dramatic decrease in the fire. So we use this for overnight burns and slower burn rates. So at this point, our fire is still getting established, so I'm going to open it back up. But once it's probably pretty important that you burn your first load of wood all the way down so you establish a coal bed. Then when you reload your next load of wood, you can adjust the air control to a medium or a medium-low burn rate, and the fire will go just fine. For an overnight burn, you're going to want to fill your stove completely full of wood and burn it on high for at least 15 minutes. You want all that wood in there on fire, nice and hot, so when you shut it down, it continues to burn and the secondary combustion system in the stove continues to work all night. So in the morning after an overnight burn, it's going to be normal for your glass to be dark. The primary air, or the air wash, which keeps the glass clean during a high burn, is controlled by your primary air control. So during an overnight burn, when you shut down the primary air to burn your wood nice and slow, you diminish the air wash. So when your glass is dark, that's normal. The stove has its own ability to clean the glass. The heat from the fire will burn all that stuff off the glass, but it needs to be really hot. So build a nice hot fire in the morning, run it on high, burn it down. It should clean your glass right up for you. What we have is a convection cast iron stove. This has two tops on it. It has a convection top and an inner top. This is the fan we put on the back of the stove. It's a 400 CFM fan and will deliver air up the back, over the top, and into the house. If you choose not to buy the fan, the stove will produce natural convection heat all on its own. Just because of the heat of the stove, it'll draw the air up the back and out the front. We strongly advocate that you buy a blower for this stove. You'll get way more heat into your house through the distribution of the airflow. Now here's a meter that shows us feet per minute in airflow. If we put this right above that, we should get some slight airflow that just due to the heat of the stove itself. Right now the blower's off. So we get about 43, well, up to 87 feet per minute of airflow on this stove. Now I have this tilted up because the airflow is coming out from this top and rising straight up. When I turn the blower on, although the airflow out the front, oh, it's terrific and it's hot. Airflow out the front with the blower on, this is on low, roughly 431 feet per minute. So that will distribute the heat from the stove throughout your house, and you'll really get a lot more heat off the stove when you have a blower on it going. If I turn this up to high, can you see that? 830 feet per minute of airflow coming out this, and it's burning my fingers. I'm telling you, this stove is a workhorse. We're so excited about it. You're going to have a great heater for your home. The control for the blower, another thing which is great about this stove, all the controls are located right here by the front leg. You have the primary air control, you have the rheostat control right here, as well as the green start igniter button. Let's talk about wood for a moment. Dry wood is crucial to get good heat output from your stove. We're going to include a moisture meter in your stove so you can measure at home the content of moisture within your wood. 15 to 20% optimal moisture content of your wood. Fresh cut wood can be up to 50% moisture, and that's by mass. So up to 50% the weight of this wood could be water, and that's going to rob energy from your stove and your house. What you want to do to measure the moisture content of your wood is take a piece of wood and split it in half. The inside of the wood is going to give you an accurate measurement of how much moisture is within this piece of wood as it burns. When you insert your moisture meter into the wood, you're going to want to run the pins with the grain. So we put it in here, The moisture meter has a low and a high scale on it. The low scale just got pegged out, so I'm going to go to the high scale. The high scale is 18%. So the inside of this wood is 18% of moisture content. The outside of this piece of wood, let's go ahead and test that. I push the high button and I'm getting no lights on the scale. So that means I got to go to the low scale. I push the low scale and we're at 14%. So that was a 4% difference between the outside of this piece of wood and the inside of this piece of wood. Remember, dry wood is crucial to getting heat out of your stove.
Hopefully this DVD has been very helpful in understanding how to get the most out of your new Lopi stove. On a personal note, if you're ever in the Northwest, please stop by, give us a call, stop by, visit. I'd love to show you how your stove is made. We have an 11-acre building that's 11 acres indoors. And we'd love to take you through, show you from start to finish how these beautiful stoves are made. And we're always good for lunch. Listen, thank you so much for choosing Lopi. Stay warm out there.